I'm chasing a signal in this watershed. Actually, two signals. One signal is that I see in the rock. I see a difference in how weathered the rock is on south-facing slopes versus north-facing slopes. It's more weathered on north-facing slopes. That's one signal. Another signal that I'm trying to understand is one that's happens over short periods of time, which is I see changes in stream water chemistry. I see changes in that chemistry that seem to be happening when there is snow melt on this south-facing slope and not snow melt on the north-facing slope. We find that the south-facing slopes melt under conditions like today, whereas the north-facing slopes retain their snow until the spring snowmelt event. So that's a very here and now kind of signal, trying to understand, well, how does water get to the stream? Why is it different from one slope to the other? Where does it come from? And what does that water do as it's getting to the stream? And it's the what does that water do is the link between my short-term, what's happening here and now question, and that long-term, how does the weathered rock evolve? Why do I see a difference from one slope to the other on the weathered rock? We want to make that link between those two time scales, which is incredibly difficult to do. We have a couple plots here, and these plots are heavily instrumented. You can see the manual snow pole, black and white and a little bit of red. You can see a camera that's trained on that snow pole, taking a picture every 4 hours so that we have a visual sentry, so to speak, measuring the snow for us. We established these plots in order to trace water in the subsurface. So there were some experiments done here where we applied a tracer, a dissolved constituent at low concentrations in some water that we sprayed over the surface of the plot. And then we just tracked where did that water go. We did that during the snow melt a year ago, during the spring. What we found is that these south-facing slopes, the flow paths for the water is quite different than on the north-facing slopes on the other side of the valley. And that has to do with the fact that the snow here is intermittent. It comes and it goes, and water is delivered in these short pulses, and then it's dry in between. That makes the water move very quickly into the soil during the brief melt events, but it leaves water behind as well, hung up in the dry parts of the soil. On the north-facing slope, there's a snowpack that builds up, and once it starts to melt, it just melts continuously in the spring until it's gone. And that causes a nice steady flow, and we saw our tracer moving very steadily through, and rapidly, but steadily through the soil profile and getting completely flushed out of the profile. So two very different flow paths under snowmelt conditions. I'm out here right now to track what happens in these early winter storms. It's November right now. This is the second snowstorm of the year, and I want to see where that meltwater goes. I think it reaches the stream or affects the stream. And dry. I have a sample. Look at that. That's water that came out of the soil since, when did I put these out? I put these out on Monday, and it's Friday now. That's fresh water out of the ground. All right, I collected a sample from this same sampler on Monday from the previous snowstorm. So this is a particularly active sampling spot. I'll have to measure exactly which site that was and get a cap for that bottle.